One galaxy wears a perfect blue ring like a crown. Yes, it is real, and it is called Hoag's object. Welcome to the Sleepy Science Channel, where space drifts gently by. There are no adverts here, only quiet cosmic company tonight. We will stroll through galaxies that look delightfully impossible. They bend light, grow rings, and glow from hidden hearts. The simple idea is calm and strangely comforting. Galaxies are experiments that run across billions of quiet years. Their patterns form slowly, like frost spreading across glass. Settle in, breathe softly, and let the universe exhale. Tonight, we meet the most relaxing oddities the sky offers. Out beyond the Milky Way, quiet shapes float in darkness. Some look familiar, with disks, bars, and gentle spiral arms. Others feel uncanny, as if sculpted by a patient hand. Astronomers call them unusual galaxies because their structures defy habit. They matter for us because surprise wakes curiosity and quiet wonder. Understanding them softens anxiety by showing chaos still follows rules. Gravity gathers stars, gas, and dark matter into long-lived families. Orbits shift slowly, while collisions rearrange everything over deep time. Bars funnel gas inward, feeding cores and reshaping spiral patterns. Tides stretch stars into streams, like salt pulled from gentle water. Jets from black holes push back, carving faint bubbles in halos. Picture a ghostly disk the size of our galaxy. But it holds only 1% the stars we carry. That is an ultra-diffuse galaxy, dim yet remarkably broad. Now shift to a nucleus blazing brighter than 1 trillion suns. This is a quasar, a galaxy powered by its center. Elsewhere, a ring stands apart from a golden core. Light piles up there, tracing orbits like pearls on silk. Each shape records a conversation between gravity, gas, and time. One-sentence recap: strange galaxies are normal physics wearing unusual clothes. They calm the mind because even weirdness follows patient steps. Timescales help too, because nothing here needs your immediate attention. You can release the day while galaxies keep their watch. They turn slowly, hum softly, and allow long breaths between thoughts. We will drift from bright hearts to delicate, whispering rings. The theme is ease and curiosity that lulls rather than jolts. Some galaxies glow from the outskirts, but others glow from within. At their core sits a massive black hole, quietly hungry. Nothing escapes the hole itself, but its dinner lights the room. Gas spirals inward, compresses, and heats until atoms scream with light. That hot disk is the engine, and astronomers named it. When it blazes at extremes, the galaxy becomes a quasar. Quasar means quas, a stellar radio source, a historical naming quirk. The point is simple: it looks star-like but is huge. Why care while trying to sleep, besides the gentle glow? Because this is order emerging from frenzy, a soothing lesson. Even near a black hole, patterns appear and hold steady. Magnetic fields thread the disk and channel out narrow jets. Radiation pressure pushes back, balancing gravity like a quiet seesaw. The disk shines across radio, optical, ultraviolet, and X-ray. Dust absorbs some light, and ray warms it into gentle infrared. So the galaxy glows in almost every band we watch. Take 3C273 in Virgo, bright even through small telescopes. It blazes with more power than 1 trillion suns. Its jets stretch for hundreds of thousands of light years. Light left that quasar billions of years before our oceans formed. Knowing this shrinks worry, because your timeline can loosen gently. Rule of thumb: bright core plus jets often signals a quasar. Astronomers observe redshift to judge distance and spectra to diagnose engines. They stack exposures, then filter noise until calm signals remain. Through patience, the picture sharpens and chaos becomes readable. That same patience can soften your breathing tonight and tomorrow. The net result is comforting. Fierce engines still follow gentle laws. Quasars are storms at sea, yet the tides remain steady. You can rest knowing the universe runs on predictability. Now imagine two galaxies drawing near, like dancers meeting at dusk. They do not smash quickly, they drift inward and exchange tides. Gravity raises tides across both disks, pulling stars into long tails. Gas clouds collide gently, squeeze, and kindle new stellar nurseries. The famous antennae pair shows bright knots across stretched arms. Those knots are starburst regions, busy with clusters and glowing nebulae. You are not seeing an instant, you are seeing millions of years. Their orbits weave, loop, and gradually settle into one remade system. Eventually, they merge into an elliptical, smooth, and centrally concentrated. This sounds violent, but stars rarely collide in these ballets. Vast separations keep direct hits scarce, which is oddly soothing. Most drama belongs to gas, which compresses and then lights up. Think of two fog banks passing while glowbugs brighten inside. Astronomers map the motions by measuring slight shifts in wavelengths. From those shifts, they trace tides like cartographers of air. The timescale helps you rest because conclusions arrive very slowly. Nothing here demands quick answers or decisions before first light. After several passes, a new calm form usually appears. It glows with older stars and little gas remains. What to remember, galaxy interactions are long arguments with soft voices. They end not in shouts but in a settled hush. The picture is peaceful despite those grand streaming tales. Let that picture hold you while your shoulders relax slowly. Some galaxies wear rings separated from their calmer golden centers. Hoag's object is the classic case, serene and almost symmetrical. A round core sits inside, while a bright blue ring encircles. Between them lies a dark gap, like a quiet moat. Astronomers think a head-on encounter may have arranged it. A small intruder could pass through, sending waves outward through stars. Those waves would shepherd gas and focus new star formation. Another option is resonance, a pattern set by orbital timing. Either way, gravity choreographs the circle, not cosmic artistry. Hoag's object lies hundreds of millions of light-years away. Its ring spans roughly 100,000 light-years across. The blue tint shows young stars, born from compressed gas. The center glows yellow, filled with older, slower-burning stars. Look closely, and you may feel a design sensibility. But remember the rule, gravity plus time explains the elegance. Example in real terms, stones dropped into ponds make circles. Waves carry pattern outward and settle into neat rings. Hoag's object offers a pond made of stars and gas. It relaxes the eye because symmetry whispers reassurance. The dark lane feels like margin, room to breathe again. Engineers study rings, and even nature recycles these patterns elsewhere. Saturn's rings echo the same dance, though at smaller scales. So the picture is harmony, built from repeated circular motion. You can let that harmony hum beneath your thoughts now. Breathing slows easily when shapes feel orderly and kind. Rings remind us that structure emerges gently from patient rhythms. Not every galaxy shines with dense crowds of stars and gas. Some are ghostly, with starlight spread thin like morning mist. Astronomers call them ultra-diffuse galaxies, large yet very faint. They can match the Milky Way's size with tiny mass. Why care while drifting towards sleep on a quiet night? Because their calm emptiness shows a different way to exist. They are held together by halos, gentle cocoons of gravity. Stars move slowly there and few collisions ever occur. In clusters, these ghosts drift like dandelion seeds in air. Some may be puffed up by tides, stretched but still intact. Now zoom outward to the cosmic web of filaments. Galaxies gather along strands, while vast voids lie between them. Gas flows down those strands, feeding clusters like slow rivers. Gravity shapes the network from tiny seeds in the beginning. We see the pattern in simulations and in subtle observations. Quasars backlight gas, letting spectrographs taste the web's faint threads. The dance is gentle, and evolution takes eons to unfold. Dragonfly 44 was once claimed to hide a massive halo. Later work softened that claim, but the lesson stayed. Measurements are fragile at low light, and patience is vital. Another case shows size like ours, with 1% starlight. That means billions fewer suns and motion that feels hushed. Example in real terms, a city built of lanterns only. Far apart lanterns glow, yet the streets still hold together. Net result, space allows many paths to structure and calm. Whether crowded or sparse, the rules carry everything consistently. You can choose the sparse path now and rest. A galaxy can hide most of its mass in shadow. That shadow has a name, and we call it dark matter. It does not glow or block light like normal dust. Still, its gravity pulls and guides stars on wider paths. This matters because everything we see is only the frosting. Most of the cake is dark, patient, and invisible. Astronomers infer halos by watching rotation speeds across galactic disks. Stars far out orbit too fast unless extra mass is present. Lensing provides support, bending background light more than starlight suggests. Simulations add dark matter and then reproduce cosmic large-scale structure. In some dwarfs, dark matter outweighs stars by factors of hundreds. Even our Milky Way swims inside a vast, unseen halo. Its mass may reach around 1 to 2 trillion suns. Only a small fraction shines. The rest simply steadies orbits. One sentence recap: most galactic mass is quiet and invisible. It is soothing, knowing hidden structure supports what you see. Your thoughts can be stars, while breath becomes the halo. Each inhale adds steadiness, and each exhale releases little concerns. The galaxy carries on, balanced by something it cannot name. We accept that mystery because the evidence adds up. Rotations, lensing, and clustering all point toward the same answer. Later theories may refine it, yet the pull will remain. You can let that certainty anchor you, gently and safely. Bottom line, unseen mass makes galaxies coherent across great distances. That coherence is a lullaby, steady and always returning. Let it hum beneath your pillow while the stars wander. Sometimes a galaxy becomes a lens, bending light from farther objects. Space itself curves there, and light follows the easiest route. The result can be arcs or even a near-perfect ring. People call that ring an Einstein ring after the equations. Why this matters tonight: rings show gravity guiding light gently. A massive foreground galaxy sits closer, and a quasar lies behind. Light spreads around the mass, arriving along several equal paths. A telescope blends those paths and paints an arc on sky. If alignment is precise, a halo ring appears around the core. Otherwise, you see mirrored smudges, symmetric but slightly offset. One famous lens shows 4 bright points called an Einstein cross. Each point is the same quasar, copied by spacetime's geometry. Another system displays a full ring, about 1 arcsecond wide. That width equals roughly a grain of sand at arm's length. So delicate, yet it reveals the halo mass with precision. Example in real terms: rainbows bend light around raindrops too. The curve feels familiar, though the scale here is vast. This is gentle geometry, showing roots through the universe. It suggests that detours can still arrive right on time. Your thoughts may wander, but they loop smoothly back. The arcs glimmer faintly, like trails of moths around lamps. Observers stack long exposures and whisper over the data. They fit curves carefully and breathe when numbers finally align. Bottom line, gravity shapes not only things but also light. That shape is soft here and perfectly safe to imagine. Let the ring hang above you like a moonlit halo. Strange galaxies show the sky is more than repeated spirals. They are canvases where matter, gravity, radiation, and time collaborate. Each one widens reality gently, beyond our first neat boxes. We started with a ring and found order in strangeness. If this calmed you, there are many more quiet corners. Subscribe for more sleepy deep space and rest when you need. Leave a gentle comment tomorrow after dreams finish their orbit. Tonight, let the universe keep watch while you drift easily. Breathe softly and feel the great structure hold you. The stars will still be here, patient and uncomplicated. Good night from the Sleepy Science Channel, wherever you are. May your dreams be ringed and gently luminous.